sustainable is tuna compared to beef, pork, chicken, or farm fish? Food systems contribute 25% of global greenhouse gas emissions. That's more than transportation. Because changing diets may be more effective than technological mitigation options, it's important to bring greater public awareness of the link between dietary choices and climate change. The same type of analysis that is used to evaluate whether a Tesla or a Prius is a more sustainable choice is needed for food systems. While the climate impact of farm protein like beef is well understood, the climate impact of tuna is largely unknown. The problem is only a handful of studies have considered the climate impact of tuna fisheries. My research addresses this knowledge gap and brings new insights. Specifically, there are 3 sustainable practices at odds with climate change mitigation. First, the use of selective fishing gears. Second, a proposed ban of fishing on the high seas. And third, the desulfurization of marine fuels. My approach is a development of a life cycle assessment model. The model is unique because it's the first to include short-lived climate forcers and the refinery emissions for taking sulfur out of marine fuels. The model can assess the climate impact of tuna under different policy scenarios. Selective gears reduce bycatch. However, as shown in A, they use more fuel. The time series in B shows a sharp decline in the use of purse seines coincident with the moratorium on drift nets and an increase in the use of selective gears. The weighted average in C shows a steady increase in fuel use over time. Banning high seas fishing would allow the high seas to serve as an ecological bank. This would restrict fishing to exclusive economic zones where the sulfur and fuel is regulated. This is important because ships are high emitters of short-lived climate-forcing pollutants, including nitrogen oxides and aerosols such as black carbon and sulfate. Sulfate cools by reflecting solar radiation and changing cloud properties, whereas black carbon warms by absorbing solar radiation and darkening surfaces with high albedo. So, as shown in D, taking the sulfur out of fuels diminishes the cooling effect of sulfate and increases the climate forcing of fishing fuels. Taking sulfur out of fuels also improves air quality, but there are added refinery emissions. The blue bars in E show a modest but significant increase in warming. Currently, tuna has a net cooling effect because over 60% of tuna is landed on the high seas. On the other hand, tuna landed within exclusive economic zones is an estimate of the climate forcing under proposed regulations. In this case, there's an equal and opposite amount of warming. Comparing this result to other farm protein, tuna has a larger climate impact across the board with the exception of beef. The definition of sustainable tuna changes when we include climate forcing in the criteria. These results can inform consumer advocacy groups and policymakers, an important step in communicating the climate impact of tuna to consumers. Thank you.
Thank you, Brandi. That was terrific. We have my wife and I have 6 kids, and they are, having been raised in Berkeley schools, they're hawkish about this, and they banned red meat. But now you've given me some ammunition to go back after them. So these are the proposed regulations would actually worsen the effect on climate change.
That's right, and that's why we really need to look at all of the policies that influence our dietary choices. And so these interdisciplinary approaches, looking at policy, looking at climate models, are important when we look at all of our food systems.
Does this also apply to other sport fishing and other?
Absolutely, because any type of fishing activities using marine fuels will have the similar climate effects when those short-lived climate-forcing pollutants are included. Yeah.
Perfect. Well, great research.
Thank you.